Good morning. Today we're going to continue our learning about arcs, angles that it's inscribed in the circle, whether it's a central angle, whether it's an inscribed angle. Let's look at the first question. The first question is asking you to assume that the diagram at right is not drawn to scale if the measure of arc QR is equal to, so I'm going to measure this arc. So this arc is equal to 180 degrees. You want to find the measure, they're asking you to find the measure of angle P. So think about it here. Before I even answer this question, this angle is considered an inscribed angle because the vertex is on the circle itself. So it's an inscribed angle. With that inscribed angle, the best way to think about it is extend the rays that makes the two rays that makes that angle and figure out what's the intercepted arc and how it's related to that angle. Eventually, the arc that corresponds to that inscribed angle is equal to 180, which is here. And an inscribed angle have a relationship with its intercepted arc, which is equal half of the intercepted arc. So if this arc is equal to 180, then this angle should be half of 180, which is equal to 90. So the measure of angle P is equal to 90 degrees, which tell us something here that QR would be definitely a diameter of the circle because the measure of this arc is equal to 180 and the measure of this arc will be 180. Recall, it doesn't look like it, but they said clearly in the question that it's not drawn to scale. The following question, you have UV is the diameter of the circle. So if this is UV, then the measure of this arc right away, it's half of the circle, so it's equal to 180. Let's see what more information that's given to us from this question. They said also TU is equal to 6. They said also that TV is equal to 8. And you want to figure out what's the radius of the circle. If I figured out what's the value or what's the length of this segment, which is UV, which is the diameter of the circle, I'll be able to figure out what's the radius of the circle. Now, I have, this is my arc is 180, and this arc corresponds to this angle that's right here, which is angle T. So if this is 180, this arc is 180, then this is an inscribed angle. Again, the vertex is on the circle itself, and this inscribed angle is equal half of that intercepted arc. And if the intercepted arc is 180, 180 divided by 2 is 90, which is say clearly that this is a 90-degree angle. Now, from there, I can see that this is 6, this is 8, and it's a right triangle. So eventually you have one side is missing in that right triangle. You can definitely apply your Pythagorean theorem, which is I can say 6 squared plus 8 squared is equal to x squared, which is your whole diameter. Moving forward from there, you have 36 plus 64 equal to x squared. X squared is equal to 100, which will make, because 64 plus 36 is 100, your x, applying the square root on both sides, it's equal to 10. So UV is equal to 10, which will make, and this, since the UV is your diameter, then the radius will equal half of that diameter, which is equal to 5. Moving on to question 26, they're asking you to compare B and C, and they're also asking you to compare D and A. So with B and C, so you have angle. Question 26 is asking you to compare angle B and C and also angle D and A. So in your notes, please connect the 2 points A and C with the segment, and then also connect the 2 points D and B with a segment. And from there, let's look clearly at angle B and C. If you see that angle B and C, both of them share that same intercepted arc, which is AD. So eventually both of them, since both of them are inscribed angles that share the same intercepted arc, so both of them would be equal to each other. The same thing with angle D and A. Both of them share the same intercepted arc, which is BC. So eventually A and D also, both of them are equal to each other. Looking at that, I can say here, before I move on to B, that angle B is congruent to angle C, and angle D is congruent to angle A because each one of those pairs share the same intercepted arc. That will give us a clear indication that the two triangles BED and triangle AEC, both of them are similar to each other by angle. Also, before I even proceed on to see that those two angles must be also equal, because either, like if you think about as the triangle angle sum theorem, because you have two angles and the third angle in each one of those triangles will be equal to each other because of the supplement, like they're all add up to 180, but also clearly that those two angles are vertical to each other, so that both angles would be equal to each other. Now, let's put more of the information from C. DE is equal to 8. AE is equal to 4. EB is equal to 6, and you want to find EC, which is, I'll name it X. Now I can set a proportion. From triangle DEB, I have 8 correspond to 8 is between the blue and the green angles, so it would be corresponding to 4 between the blue and the green one. That should equal to 6 over, and the 6 is between the red and the green, so it will correspond again with the side that's between the red and the green, so 6 over x. From there I can do my cross and multiply, so 8x equal to 6 times 4, 24, 6 times 4 is 24, equal to 8x divided by 8 on both sides, so x is equal to 3. Moving on to question 27, when you have an when you have a quadrilateral inscribed in a circle, you can say clearly like the opposite angles are supplementary to each other. So x and 100 are both supplementary to each other. So I'll have here, I can set up an equation, x plus 100 is equal to 180. Subtracting 100 from both sides, then x is equal to 80. Let's move on to question 28. And with 28, you want to find A, B, and C. For each A, B, and C, you want to find the value of x. If I look at this diagram from A, they said that KL and MP intersect at Q, and you want to find x given that KL is equal to 8. So if KL is equal to 8 and you have this part is equal to 2 here, then the remaining part, which is KQ, is equal to 8 minus 2, which is 6. Now, before I even set my proportion, I want to make sure that you understand that, again, those two triangles are similar. Angle M is congruent to angle L because they share the same arc, which is KP. Also, K and P, angle K and angle P are congruent to each other because they share the same arc, which is ML. Finally, you have two vertical angles here. So I can set a proportion to find the value of x. So I'll put 3. It's between the blue and the green, correspond again to the side that's between the blue and the green in the other triangle, which is 2, equal to 6 between the green and the red, correspond again to x. From there, I can do my cross and multiply. 3 times x equal to 2 times the 6. So you have 12 is equal to 3x. Dividing by 3 on both sides, x is equal to 4. With this question, they're all what they didn't give you any numbers, but they said that RT is a diameter in this circle. They said that eventually those two, they have the same symbol along with this side, which is RS, have the same symbol as like the radius. If I extend from the center to S, I will end up also with a radius. So recall that this is a radius. This is a radius. This is a radius as well. And this side, which is RS, have the same symbol as your radius. So you're ending up with an equilateral triangle here. And with an equilateral triangle, all of the angles in any triangle is equal to 180. So you're dividing that by 3. So each one of those angles would be 60. So measure of angle X is equal to 60 degrees. With this question, you want to find the value of X, which is arc FG. So this is eventually what you need to find. I have this part, which is arc EG, is equal to 131. If I succeeded to find arc FE, it would give me a chance to find the remaining, the arc FG, because all around is equal to 360. So this arc, which is FE, correspond to the inscribed angle G, which is FGE in specific. So if angle FGE is equal to 52, then the arc will be equal double of the inscribed angle, which is equal to 104. Now I have 2 out of the 3 pieces for the whole circle. So X plus 104 plus 131, it's all equal to 360. Now X is equal to 360 minus 104 minus the 131, which will make X is equal to 125. Last question for the section. You want to find LM, segment LM, given that the measure of arc LM is equal to 150. So I'll just draw this one. This is 150. They gave you also that the radius is equal to 6, and that's all what's given, but you want to find the measure of chord LM. I'll draw a triangle using the 2 radiuses and the chord. Eventually, this is 6. This is 6. LMP as an angle is a central angle because the vertex is on the center of the circle. So if this is 150, then the measure of this angle is 150. Now it's leaving us to figure out what's the length of LM, which is segment LM. Now I have multiple ways eventually to find the side. I can take that triangle out, and I'll put here 6 and 6. This angle is 150, and I'll put here X. I can take this triangle and divide it into 2 right triangles, and I can apply my SOHCAHTOA to find the base. I can also figure that out by using the law of cosines, because you have 2 sides and an angle that's included between them, and you want to find the side that's linked to this angle. So X squared is equal to 6 squared, so I'm applying my law of cosines, plus 6 squared minus 2 times 6 times 6 times cosine of 150. And then you're doing the square root of this whole big equation. I would say please make sure that your calculator, first of all, is in degrees mode. And you're applying this whole command in one big whole step. That will lead to say that X is equal approximately 11.6. Make sure that you're writing the notes along when you're watching this video. You have clear instruction in your Google Classroom. After you're done with this video and write the notes, make sure that you upload your notes and then start your assignment, which is one assignment that you will see on your Google Classroom, and have a great day.